Today's video is dividing rational expressions. The great news is if you can multiply rational expressions, you can divide them. So remember that when we divide fractions, all we are doing is flipping the second term and then changing the division to multiplication, and then we're right back to multiplying rational expressions like we did in the previous video. So we still want to find restrictions. Then we are going to change that second term. We're going to flip it and change our division sign to a multiplication sign. And then we're doing multiplication. We simplify what we can. We multiply our numerators, then multiply our denominators, and simplify if there's anything left to simplify. So let's go ahead and get busy and do some examples. Okay, so here's our first example. Remember that we always want to put a 1 underneath. Now the first thing I'm going to do is my restrictions, just like we have been. So I want to focus on what's on the bottom and where we have a variable. Well, I don't have a variable in either one of my numerators, so I actually end up with no restrictions here. Okay, because at the moment it's not actually, neither one of these are rational expressions. They're both just fractions. So next step is to flip and multiply. So I'm going to rewrite this 14h over 15 times 1 over 16h. Okay. Now at this point we are ready to start our multiplication process. So I can see that I have an h here and an h down here. So h divided by h is 1. So I'm going to go ahead and I'm going to multiply straight across. 14 times 1 is 14. 15 times 16 is 240. Well, now I didn't catch it before I multiplied, but I can see that 2 will go into both of these numbers, won't it? So 14 divided by 2 is 7. 240 divided by 2 is 120. And this is my final answer. So there I actually had to simplify again after I multiplied my numerator and denominator, which is okay. All right, let's do a second example. Okay, here's my second example. I have a whole number, so again, I'm going to put a 1 underneath there. Looking for restrictions, I do not have a variable in either one of my denominators, so again, I have no restrictions. So now I am going to go ahead and I am going to flip and multiply. So 5x squared over 1 times, let's make that a dot, and I'm going to flip this fraction 9 over 10x now. Okay, so I identify that I've got an x down here and an x squared up here. So I am going to subtract the 1 down here from my squared up there. So that cancels out, and this becomes just an x. Now I also notice that I've got a 5 up here and a 10 down here. 5 will go into 10 2 times. Let's make that a black 2. Okay. So I have simplified, and now I'm going to multiply straight across. So I end up with a 9x on top. I'm going to multiply straight across. 1 times 2 is 2. Now as you notice, it can get confusing as you cross things out. So if you need to write extra steps to keep it clean, go ahead and do that. I cannot simplify anything further, so I'm going to leave it as 9x over 2. Let's do another example. All right, so this problem's got a lot more stuff to it. So first, let's factor everything we can. We can't factor, let me go back to black. X minus 3, that's as simple as it can get, and the 2x plus 1 is as simple as it can get. I can factor 6x squared plus x minus 1. I'm going to have you pause and work through that and then come back and make sure you've got it right. You should have gotten 3x minus 1 times 2x plus 1. And then the x squared minus 9, that's a special case, so I know I've got x and x, plus and minus 3 times 3 is 9. Okay, now we're going to look at our restrictions. I've got a 2x plus 1, an x plus 3, and an x minus 3. So 2x plus 1 equals 0. We're going to solve. We get x equals negative 1/2, which means x cannot equal negative 1/2. Then x plus 3 equals 0. So x can't equal negative 3. And then x minus 3 equals 0. So x can't equal positive 3. And again, remember, if you put this equation into the calculator, you should have asymptotes or holes at these 3 places. Okay, so we have found our restrictions. Now we are going to flip and multiply. So x minus 3 over 2x plus 1 times the x plus 3 times x minus 3 goes on top. The 3x minus 1 times 2x plus 1 goes on bottom. Now, is anybody noticing what I'm noticing? Nothing here is going to cancel out. And sometimes you'll get a goofy problem like this, especially when Miss T makes it up herself. So, multiplying straight across, we have x minus 3 times x plus 3 times x minus 3. We should have made this a multiplication problem. And 2x plus 1 on bottom, multiplying straight across, times 3x minus 1 times 2x plus 1. Now, we are just going to leave it like this. The practice of factoring was actually way more important on that one. Okay, I'm going to give you one last problem. You can try it on your own and then hit play again and see if you got it right. Okay, here is your example. Remember, we want to go ahead and factor our 2 denominators before we do our restrictions. So hit pause, factor that, come back and see if you factor them correctly. Here are the correct factored forms. We'll wait and factor the numerator here in just a second. Go ahead and find your restrictions, hit pause. Alright, so our restrictions should be x cannot equal negative 5, x cannot equal negative 2, and x cannot equal positive 2. Again, if you will actually put these 2 equations, put them into the calculator, you're going to see, you're going to put these equations into the calculator and you're going to see those asymptotes or restrictions. Alright, so let's go ahead and I want you to go ahead, flip and multiply, solve it, and come back and check it. Alright, so once you factored everything, flipped and multiplied, this is what it should have looked like. And if you're not quite done, if you just needed help on that, hit pause again and come back to see if you get it right. I'm going to go ahead and finish solving. So I'm going to divide x plus 5 by x plus 5. I am going to divide x plus 2 by x plus 2. When I look over here, I do not have anything else that is alike, so I'm going to multiply straight across. And I have an x minus 2 on top. Down here, I have an x plus 2 and an x plus 3. So this is your final answer. All right, good luck. Get your practice in.